Today's video is about multimeters. Multimeters can measure a range of values of current in amps, potential difference in volts, and resistance in ohms. They do this by using a big selector switch. The dash with a dotted line below it is direct current. The wavy line is an alternating current. So for a 10 amp ammeter, you would select that setting. If you want it as a voltmeter, you'd go around to there. 20 amp DC, 20 volt DC is there. When you're using them as an ammeter, you use the common terminal, and if you're using the 10 amp scale, you use the 10 amp socket. This either has a 10 amp fuse or no fuse at all. If you're using a amps or milliamp setting, use the common and the milliamp. On this one, an amp and the common setting. On the current settings, the 10 amp and the milliamp sockets, the meters will allow electricity to flow. If you were to connect them across a component as a voltmeter, there's a big risk you will blow the fuse. There's a simple way to test fuses. If you have more than one multimeter, if you put one of the multimeters on resistance, you can see that it reads 1 at the moment. We're using the common and the resistance sockets. And then if we put another multimeter to test onto its milliamp setting and plug into the milliamp sockets, you can see the reading goes down, showing we've got very little resistance, so the fuse is intact. If we were to look at one where the fuse is possibly blown, using the common and the current one, see the resistance reading is staying at 1, so it's very high resistance, and the fuse in that one is blown. Fuses are usually little glass encapsulated fuses, and you have to take open the meter up, and this one I've actually taken that fuse out rather than blow one. We can replace it with a like-for-like fuse by just slotting one in, screwing the meter back together. So now that we've done that, plugging in, gives us a low reading on our test meter. So that fuse is now okay. You have to select milliamps on ones without separate sockets. These ones have got a voltage, ohms and milliamp socket, so you have to switch it to milliamps to test the fuse, because that switches that socket to one that has the fuse in line with it. On the voltage, it wouldn't pass any current. There wouldn't be contact, so it would look as if it had a blown fuse. Most of these are the ones with separate sockets for voltage and current, voltage and resistance, and separate ones for current. You don't need to select the appropriate milliamp or amp scale. If they're fused on the 10 amp one, you plug your test leads into the 10 amp and common instead of the current one. A couple of tips to avoid blowing fuses. Always start on the 10 amp setting and the 10 amp sockets, if you're going to measure current, if you get a reading above 0.2 amps, that's 200 milliamps, then you know you're going to blow the fuse if you're going to switch to the milliamp scale. So don't do that, just use the 10 amp scale. The other tip is always switch the meter, or switch the circuit off before connecting your meter. If you connect in to, if you change it from voltage to current, for instance, and switch the terminals on the meter with the current still on before changing them in the circuit, then you'll blow possibly the 10 amp fuse. If that's plugged in as a voltmeter across a bulb with just a power supply, then that's going to blow a 10 amp fuse. Similarly, if it was plugged into the milliamp scale, you'll blow a milliamp fuse. You can get resettable fuses for multimeters. These are a type of thermistor whose resistance rises as the current rises, so they will shut off the current above a certain value. You have to solder these inside the casing, take the existing fuse out and solder the component across those terminals. We've got them fitted in these meters on the 200 milliamp or the milliamp fuse instead of a fuse, and we haven't had any problems since we've done that.